In lesson 3.1, we start learning how to solve for equations, which is the backbone of algebra, solving for equations. We're going to first start learning how to solve one-step linear equation, which means we need to understand and identify what linear equations are. And linear equations are those equations in which the highest power of x is 1. Like in this example, remember, when an x or any number doesn't have an exponent, the default exponent is a 1. So we can write here a 1, and that makes this a linear equation because the highest exponent we have for x is 1. So that's how we can identify linear equations. When the higher exponent of x or any variable, any letter that we have in the equation is 1. Let's look at a few examples. This one, the x is to the power of 2. We have 1x to the power of 2. It doesn't matter that the other ones are to the power of 1. As long as one of them is to the power of 2 or higher, or any different than 1, it's not a linear equation. So we can delete it from the screen. Let's look at this other one. The x is on a square root, which if we recall from the basic algebra course, square roots is the exponent of 1/2, which is not 1, is not a power of 1. It doesn't matter if we have other thousands of x's to the power of 1, as long as one of them is not to the power of 1, it is not a linear equation. Let's look at another example. This one might be tricky because the x is on a fractions, and fractions tend to scare us. But we don't care about the coefficients. We don't care about the numbers x is being multiplied or added by or subtracted. We care about the exponent of x. And this x is to the power of 1. That makes this a linear equation, and that's how we can identify linear equations, by the highest exponent of x to be 1. Now that we know what linear equations are, we can move on to one-step linear equations. One-step linear equations, as the name says, are equations we just need one step to solve for the equation. Like in this case, x plus 3 equals 12. But before we learn how to solve this, let's understand a little bit about the behavior of equations. Equations have an equal sign. What this equal sign represents is the right side of this equation must be equal to the left side of this equation. It doesn't matter what we have on both sides. When we add them, multiply them, divide them, when we do all the math operations, both sides must be equal, must have the same value. That is why they're called equal signs. Next thing is, when solving equations, our objective is to isolate the x, or whatever variable we have. We can have many different letters, but in this case, we're solving for x. Now, since we're solving for x, we need the x to be fully by itself. We need the x to be isolated. In this case, it's not fully isolated because the x is being added a 3. That 3 is not letting the x to be by itself. So that means we need to take that 3 and move it to the other side of the equation so the x can be isolated. But how can we do that? How can we move that 3 from the left side to the right side? That's when we do something called inverse operation. Inverse operation, in other words, the opposite operation. Here we have a positive 3. That means addition. What is the opposite of an addition? The opposite of an addition is a subtraction. So what we're going to do is make a negative 3, a subtracting 3. And the reason why we do the opposites in algebra is so we can cancel them. Opposites in algebra cancel. Positive 3 and negative 3 cancel each other. And that's it. We got the x to be isolated. Well, we solved the first objective, which is the x to be isolated. The 3 is no longer there. We eliminate it. But we have to remember a golden rule in algebra, and it is what we do on one side of the equation, we must do it on the other side of the equation. So if we make a negative 3 on the left side of the equation, we have to make a negative 3 on the right side of the equation. Is the rule. And now we just do the operation. 12 minus 3, that's 9. So we got now x equals 9. The x is fully isolated. The x doesn't have any other number on the left. So that's our answer, x equals 9. As soon as the x is completely isolated, we get our answer. But let's practice with another problem. We want to isolate the x. It is not fully isolated. It's not by itself because we have a -7. We need to move that -7. So we need to do the inverse operation of a -7, of a subtracting 7. The opposite of a subtraction is an addition. So if we have a subtracting 7 and -7, we put a positive 7 and adding 7. And we can cancel. Opposites cancel in algebra. But the problem is not over there because the golden rule, what we do on one side, we must do it on the other. So we must make also a positive 7 on the right. The 7's canceled already on the left, and 8 plus 7 is 15. So we get x equals 15. The x is now by itself, so x equals 15. And that's going to be the objective every single time we're solving equations. Having the x completely, or whatever letter, sometimes the letter changes, but having that letter, having that variable completely by itself on one side of the equation. Let's do one more problem. One more time, our objective is always going to be to solve for x, to isolate the x. This might look scary because fractions tend to scare us a little bit sometimes, but the idea is the same. Even if we have a fraction, we have to move that fraction to the other side. And for that, we're going to be doing inverse operation. That fraction is subtracting because it's -1/2 or -1/2. So we have to use the opposite of a subtraction, which is an addition. If we have a -1/2, we make it a positive 1/2 because opposites cancel each other. -1/2 and positive 1/2 cancel each other. But what we do on one side, we must do it on the other. So we also have to do plus 1/2 on the right side, leaving us with 2 plus 1/2. This is an addition of fractions. We learned it on lesson 1.3 of the basic algebra course. You can review that video if you would like a refresher, or you can pause the video and take a look at the equation that is showing there. 2 plus 1/2, we get 3/2. X is isolated, so x is equal to 3/2.